Good afternoon to all honorable audience here, and thank you for the opportunity that has been given to me. My name is Yayan Marian, and in this section, I will present my research with the title Hydrodynamic, Tidal, and Monsoonal Current Characteristic in Pondok Dayung Port of Tanjung, Priok, Jakarta. Pondok Dayung Port is a new port at Tanjung Priok Harbor. So because it's a new port, so that have very little bit information about that port. So in this picture, you can see this is a Tanjung Priok Harbor, and in the inner red line is my research area, and this is a Pondok Dayung port. So one of the most important information from a new port is the hydrodynamic characteristic, which are very influential in terms of shipping safety. So from this reason, it will make face the recent question, how are hydrodynamic characteristic in the research area, and how fast is the ocean current speed in the research area. So in this research, I'm using a numerical model method with the application of Mach 21, and the research began with the preparation of data such as bathymetry is taken from digitizing Indonesian marine chart number 86 alpha, and the coastline line data is taken from digitizing Indonesian marine chart number 85 alpha, and the tidal data is taken by global tide prediction at Mach 21 application, and wind data is taken from the loading from EGMWF website. So after all data is ready, we can set up in the application Mach 21 flow module FM to create the domains model and to input the initial condition. And the model will running in January for representative on West Monsoonal condition, and in the July as representative in East monsoon condition. So after the model is complete, the next step is validation of model simulation with comparison with the observation data sea surface elevation from Tidal station owned by Indonesian Geospatial Agency. And then if the validation are good, we can analyze the result of model, and then the last step is conclusion. So this is a picture of the main model by modeling using the flexible mesh or triangular mesh, and the total number of mesh is 3,840, and the large mesh size is 2.52 nautical miles square, and the smallest allowable angle of triangle is 26 degrees. And this is picture the focus area or observation area, and then station 1, stations 2, station 3 are located in the inner jetty pool. The station 4 are located in the entrance of jetty pool, and the station 5 and station 5 are located in the entrance of jetty channel. So this is a picture of this is a picture comparison graph of sea level elevation between the model result and the observation data in January. We can see the blue line is the observation data, and the orange line is model simulation data. We can see in the picture there's not much difference between the model result graph and the observation graph. So based on calculation using the Admiralty method, we get from cell value the observation data show the type of tide in the research area on January is diurnal tide, and the model result also show the same tidal type too. And based on calculation using the root mean square error method, so a value 0.045, we saw that the simulation model is close to the real condition based on Q and Bentel research in 1998, which state that a simulation model is said to be good if it has an error rate below 0.05. And based on correlation calculation using the Pearson product command, we get value of using the Pearson product command, we can get value 0.9843, which means that the simulation result of the model have a strong relation. And this is picture. This is picture of graphic comparison of sea level elevation in July. We get from cell value in July, both of the simulation result on the model and the observation data show the diurnal data type 2. The error rate in the July simulation result in 0.0432, which means that the July simulation model is also close to the real condition, and July's correlation value so a value are of 0.9814, which means that there's a strong relation between model simulation and observation data. So this is picture of simulation model of water current at January. We can see in the picture when the conditions are toward the flood tide, the ocean current lead into the pier pool. You can see in the current pattern lead into the pier pool. Sorry. Otherwise, when condition toward ebb tide, the ocean current is come out of the pier pool. We can see when the toward ebb tide, the pattern current is come out from the pier pool, and then this happened during spring tide and neap tide condition. And this is a picture of simulation result of the current pattern model in July. We can see in the picture, the current pattern in July is also as same as the current pattern in January. And when the condition is toward to flood tide, the current pattern is lead into the pier pool, and when the condition toward to ebb tide, the current pattern is come out from pier pool. So we can take a conclusion. This is so that the pattern of ocean current in the research area is not strongly influenced by wind, but is more influenced by tide and the shape of the coastline. This is a picture of graph of the speed of ocean current at observation station in the research area when where the station 1, station 2, station 3 are located in the jetty pool area, and station 4 are located in the entrance of jetty pool, and station 5 are located in jetty pool entrance channel. So, and we can see on the graph of January and July, we can see a very significant difference between the speed of current outside jetty pool. You can see this is outside jetty pool and inside jetty pool. So we can take the conclusion is from that the breakwater in the research area is very effective at holding the current velocity, so that the current velocity in the pier pool area is smaller than outside the pier pool. So this will make it very easy for the ship when it will dock at the Pondok Dayung pier. Then this is a picture of comparison graph between model simulation using tidal effect and model simulation with tidal and wind effect. We can see in the picture the black line in the result of simulation with the influence of tide only, while the orange line is the result of a simulation with the influence of tide and wind effect. So we can take conclusion from this picture. The influence of tide and wind on current speed can be seen by the high current speed when the wind direction is in the same direction as the current pattern at time of high tide. Finally, we come to the conclusion. First conclusion, this hydrodynamic simulation show a high tendency to reconstruct the dynamic condition of sea level elevation and current and Pondok Dayung form. And the underlying characteristics are possibly influenced by tide rather than the wind effect in both the west and the east monsoon. However, under certain conditions where current movement occur due to tide in the direction of the wind gust and increase in the driving force tend to also accelerate the current speed. And the second concludes, this circumstance indicate a very effective breakwater construction as a sea wave protector toward ensuring the ship's stability and safety during maneuvering and dock operation. This result serves as a possible reference for captain in the navigation planning process ship maneuvering the port basin area, particularly by considering the direction and current speed in the jetty island. So my research is acknowledgement all authors having equal contribution as principal investigator. The study is collaborative research among the Marine Research Center of Costa Rica, STTAL, and the National Center for Hydrography and Oceanography or HUSHIDROSAL in the framework of the Indonesian Hydrography Council Communication Forum. Furthermore, the research was conducted before the COVID-19 pandemic at the Marine and Coastal Data Laboratory, Marine Research Center, the Republic of Indonesia Ministry of Marine Affairs and Fisheries, while the author discussion conducted virtually during the pandemic. The manuscript preparation and its publication funded by the STIL fiscal year 2021 for the research project of the Path to Fusion Oceanographic System prototype development. The map legend in the figure 1 was plotted using the ocean data view. So that's all my presentation. Thank you for your attention. Good afternoon.